Welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy Semester Exams. We were discussing network analysis and transmission line crash course and transient, and today the topic for today is transient and steady state response. In that, we'll be discussing what is initial conditions. What is initial conditions? So before that, let me tell you about myself. I am sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and also cracked GATE. So let me also tell you about the Unacademy learning app installation procedure. Just type Unacademy learning app, and in step 2 click on this install. Then you can click on this GATE and engineering services and click on this plus and click on get subscription. So you have both plus and iconic subscription. You'll have a dedicated mentor for your preparation for iconic subscription. So you can use my code as YSK10 to get the maximum discount of 10%, and you can click on this proceed to pay. When you do that, you have payment options like debit card, credit card, EMIs, UPIs, wallets and net banking. So you can use any of these platforms and get subscription to the Unacademy. So the topic for today, before getting into topic for today, let me also tell you about the Evolve and Ascent for GATE 2022, which is one of the greatest initiative of Unacademy. We have electrical batch A both in English and Hindi, which starts on 21st of December by our top educators like Ankit Goyal sir, Ajay Gupta sir, Hafiz sir, and BB Reddy sir and Suresh sir. So those students who are opting or planning to crack GATE 2022 can join this Evolve GATE 2022 or Ascent GATE 2023. Get subscription to Unacademy. You'll get a lot of things to know and easy methods to crack GATE 2022 and 2023. So the topic for today is transient and steady state analysis, and initial conditions is our topic under this transient and steady state analysis. So let's look at that now. Let's look at that transient and steady state analysis. Transient and steady state analysis. What is this transient and steady state analysis is? Let us say, let us assume that there are some energy storage elements in the circuit. Let us assume that there are some energy storage elements present in the circuit. Let a network consist of, let a network has some storage elements. What are the storage elements? Like inductor and capacitor. Inductors and capacitors. Now if that is the case, and if this network is switched, or if there is any disturbance that is caused to this system, then it will change its state. It will change its state from one condition to the other. That is the state that a system undergoes before that a system undergoes before that a system undergoes before it reaches steady state. is known as transient, is known as the transient state. Let us say there is some disturbance. Let us say you have a system like this, and I'm just trying to plot the system. You have a system, and we are just trying to plot the response. So what happens is the system, when it is switched from one state to the other state, it will change. It cannot instantly reach, it cannot instantly reach the maximum value, but it will slowly, steady state value, it will slowly attain its steady state value over a period of time. And this period of time that is taken, let's say this is some c of t and this is t. Now let's say this is the time, that is phi time constant it is taking to reach this steady state. So this is called as steady state, and this is called as the transient state. This is called as the transient state. Steady state and transient state are the two states. So this is transient state and this is steady state, and the analysis that we perform here is nothing but this transient analysis, and the analysis of the response or finding the response of the system in steady state is called as the steady state analysis. You have both steady state analysis and transient state analysis, right? Some student were asking me about the clarity of the sub screen. Just once again, I'll just tell you, I've been telling you this from this first video. If you have if you are watching this on your mobile, just do click on the three dots that are available at the top right corner. If you click on them, there will be a pop-up, and in this pop-up you can find a report. Second one will be quality, and you also have the rest of the things. Click on this quality, then again you'll have a small pop-up that is coming out like this, wherein you have auto 144p and so on. You have 480p. Click on this 480p. So just emphasize on this. Click on this 480p. Then you will have a clear video. Then you'll have a clear video, right? So this is for better video quality. For better quality of video, I'm just telling you this. Now let's look at the thing that I have told you. So the response of a system before it reaches steady state is known as a transient response. Before it reaches a steady state, it will have a transient response. In general, this transient response can be oscillatory or exponential. And let me write the response. The response of a system after transients die out is known as a steady state response, that I told you just now. Steady state response. And this transient response, as I have told you, this transient response can be of two types. Let me draw that. In practice, the system response can be of exponential. The transient response, to be specific, can be exponential. That's, let us say I'm giving some input as this. Let's say this is the input, and for this, if I get something like this, it is an exponential input. This is an exponential response. This is the desired one, this is the actual output. So this is c of t versus t, or this is also c of t versus t. Now you can also get it something like this, an underdamped system. This can also be the response. So this part of the response is called as, this part of the response is called as, this part is called as transient response, and this part is called as the steady state response. Similarly, if you can just take this here, this part is called as the transient response, and this part is called as the steady state response. So we'll just try to write it. So this is transient, this is steady state. So this is an exponential response, this is an oscillatory response. So you can have either exponential response or an oscillatory response, right? So this is about transient response and steady state response of a system. Now what can we infer from this is the total response of a system, the total response of a system is equal to, it is the sum of transient response and steady state response. This is the total response of a system. The total response of a system is the sum of transient response plus steady state response. You can also write this as C of t is equal to transient response plus steady state response. You can also represent it this way. If C of t is the output of a system, given system, right? Now let's see what are the initial conditions. That is what is our topic for today. Now I'll just give you an example first. Let's say you have a circuit previously like this. You have one circuit. Let's say a capacitor is connected like this to this circuit, and let me do this something like this. It will be easy. Let's take this one more line, and let's say this is a switch. Let's call this as a switch. This is 1, this is 2, this is the voltage V, R, and capacitance C. Now what happens? Let's say this switch is connected to 1. Now when it is connected to 1, the capacitor gets charged. When it capacitor gets charged, let's say we are just connecting at 1 for a long time, so it's fully charged. When I switch it to position 2, that means there is no supply to this capacitor, and now it starts discharging. Now it starts discharging. Now when I take the instant when switch is moved from 1 to 2, when the instant when I take between this 1 and 2, when moving switching from 1 to 2, you can say at 2, at the position 2, when the switch is on, at when you are connecting the switch to 2, we can say the initial value of the capacitor is, or the voltage across capacitor is equal to the applied voltage VA. Similarly, that means if it is already charged, that has to be considered. So you have initial conditions for an inductor as well as a capacitor. Inductor and capacitor, because voltage across a capacitor and current across an inductor does not change instantaneously. So here we will define what is called as initial conditions. We will define something called as initial condition. It is, what is the initial condition? It is the state of the system, the state of the element, or it is the state of the system just before just before its state change, before its state change. So for a capacitor you will have a voltage, and for an inductor you'll have a current that is flowing through this, and a voltage across a capacitor and current through an inductor are the initial conditions that are to be considered. So let us say, if you have let's say some, let's take it as some table. I'll just draw it as a table that will be easy for you. So if this is the table that is considered, if this is the table that is considered, this is the first column will represent the element, and the second column is t is equal to 0 minus, third column is t is equal to 0 plus, and fourth column, let's say t is greater than 0 or t is equal to infinity. Now if you say this is the first column is, I'll represent it in terms of element. The first element will take it as a resistor, and we'll take t is equal to 0 minus, and t is equal to 0 plus, and t greater than 0, and t is equal to infinity. Now at t is we'll consider first element, second element, third element. I'm just assuming that all these three elements, inductor, resistor, inductor, capacitor, anyway resistor does not store anything, but inductor and capacitor, I'm assuming that they are they did not store any energy. So at t is equal to 0 minus, so the resistor at all the cases will behave same because it is not an energy storage element. It will behave as the same. But when you are considering the inductor at t is equal to 0 minus, if it is acting like an inductor, now at t is equal to 0 plus, when the instant there is a switching, let us say there is a switching between this t0 minus and t0 plus, it will act as an open circuit. It will act as an open circuit because it does not allow sudden change of current, and so current is equal to 0. And a capacitor at t0 plus, at t0 plus, it will act like a short circuit. It will act like a short circuit. And at t greater than 0, let us assume that the inductor is same, and at t is equal to 0, t greater than 0, and it will act like a capacitor. And at t is equal to infinity, inductor will act like a short circuit and capacitor will act like a open circuit. But here you have to see that this inductor and capacitor at a t0 minus and t0 plus, the values will be same because it will not allow sudden change of current and it will not allow sudden change of voltage. So this will behave as open circuit and this will behave as a short circuit. Now that depends upon the given question, these values. Again, if it is already charged, then you will have this will behave as a current source and this will behave as a voltage source. So let me also explain you that. Let us consider an inductor. Let us consider an inductor. So V is equal to L di by dt. At V is equal to L di by dt. Now at it does not allow sudden change of current. It does not allow sudden change of current. So voltage across this will be infinity approximately because it will act like a open circuit. Now if you take a capacitor and the voltage V is equal to 1 by C integral I dt, or you can also write it as I is equal to C dV by dt, and this current is equal to 0 or voltage is current is equal to infinity or voltage is equal to 0, it will act like a short circuit whenever there is a switching operation. Whenever there is a switching operation, it will act like a open circuit and it will act like a short circuit whenever there is a switching operation. So generally we will represent switch like this. So this is a switch and you also have to know about this switch. So let us see that about switch. So if you represent a switch like this, and if you represent a switch like this, there can be two cases. One is it is represented like this and it is represented upward and it is represented downwards. Now these two are the two cases that we have. Now if this is the case, first one is the case, it means so at t0 minus switch is actually open and we are switching it on. That means it is we are closing it in the first case. This is the first case for the first case. And at t0 plus at t0 plus at t0 plus we are switching this on, right? So we are closing it and it is on, and this is in off state when t0 minus. Now if you consider the second case, if we assume this as the second case, and if you observe this arrow, you can say that at t0 minus and at t0 plus, at t0 minus the switch was already on or close, and at t0 plus switch is said to be off because we are making it off, or it is said to be open. So these are the two conditions that you need to, two types of representations of a switch, right? So let us try to analyze some problems. Let us consider two or three problems and try to solve those circuits and see what are the initial conditions given. So the question is given something like this: find I of 0 minus 0 plus I of 0 minus and di of 0 plus by dt, d square I of 0 plus by dt square. This is the question for the given circuit. For given circuit when switch is operated. When switch is operated, this is the question. Now let us consider that question. The question given is something like this. There is a there is a supply voltage with some switch with a resistor and an inductor like this, and the values are given. Also switch is given like this. This is plus minus 100 volts and you have 10 ohms and 1 Henry. So if you look at this question, the first thing that you have to do is observe the switch, whether it is from off to on or on to off. So at a t0 minus, the switch is open and we are making it on, right? So it is open. So this is off. Now at t0 plus, you need to observe the switch is closed. At t0 plus, the switch is closed. We are switching it on. So this is the switching operation. This is the switching operation that we are doing. We are switching from off state to on state. We are switching from off state to on state. So now let's try to look at that. Now what are we asked to find? I of 0 minus I of 0 plus. So first let's try to draw the diagrams for this. So first one is for t is equal to 0 minus. Second one is for t is equal to 0 plus. Let's try to draw this. For t is equal to 0 minus, the switch is open or it is off. So you can just draw it like this and we can say it is off. There is a resistor and an inductor. So this is plus minus 100 volts and it is open circuit. Right? You can say it is open, or you can also write it as off. You can write it as off. And this is resistor value 10 ohms and inductor 1 Henry. Now in this case, if you observe, and let's also try to draw at t is equal to 0 plus. At t is equal to 0 plus, the switch is on and there is a resistor and there is an inductor. We'll try to analyze what happens to this inductor. And now we can say this is on and this is plus minus 100 volts. Just look at this. What will happen now? Just look at this and write what is current I of 0 minus. Current at t is equal to I of 0 minus is 0 amperes because there is no current because it is off. Now let us consider for t is equal to 0 plus. Now whenever you take t is equal to 0 plus, there is a sudden flow of current I and inductor does not allow sudden change of current. So it will behave as a open circuit. it will behave as a open circuit. So what is the current in this case? 0 plus also at an instant when you switch it on, it is also 0 minus is also equal to 0 amperes. So T0 minus, here switch is off, here the switch is on. You just have to write switch off here, and here the switch is on. Now when the switch is off or when the switch is on, it is 0 amperes. So inductor does not allow sudden change of current. Now when suddenly inductor acts as an open circuit. Now after some time, if you can consider at a t greater than 0, if you say for a t greater than 0, now inductor switch is on, there is a resistor and an inductor that is placed, and you have this 10 ohms and it is on. This is plus minus 100 volts, and what is this value? 1 Henry. Let's say there is a current that is flowing. Now what is the equation that you write? Apply KVL. How do you apply? 100 is equal to 10 into I plus L, 1 into L di by dt, right? So can I write it as 100 is equal to 10I plus L value is 1, so di by dt. Now I want to find di by dt at I is equal to 0 plus. Can I write it as di by dt is equal to 100 minus 10I? From this, if I want to find di of 0 plus by dt, what is that? 100 minus 10 into I of 0 plus, because this is I of 0 plus. So this value will be 100 minus 10 into I of 0 plus. You already know it is 0. If you just observe here, what is I of 0 plus? It is 0. So what is that you'll get? So di of 0 plus by dt is equal to 100 I by t. It is ampere per second. So di of 0 plus by dt is equal to 100 ampere per second. 100 ampere per second. Similarly, you also need to find in the given question. See, we have found, if you observe, what are the things that we have found? We have found I of 0 plus, I of 0 minus, di of 0 plus by dt. Next, we have to find d square I of 0 plus by dt square. D square I of 0 plus by dt square. For this, just consider the same differential equation and differentiate it. So just consider this differential equation. This is the third part that we have done. Now we are doing fourth part. So d square I by dt square by differentiating is equal to 0 minus 10 di by dt. If you differentiate 100, it is 0. So what do you get? D square I of 0 plus by dt square is equal to 0 minus 10 di of 0 plus by dt. What will this give you? D square I of 0 plus by dt square is equal to minus 10 into, already you have 100, so ampere per second square. So d square I of 0 plus by dt square is equal to minus 1000 ampere per second square. So this is the answer that you get for the d square I of 0 plus by dt square. So let's see once again what we have done till now. There is a given question and we are asked to find this I of 0 plus I of 0 minus di of 0 plus by dt, and also d square I of 0 plus by dt. Welcome Krishnachari, welcome DJ Vicky, Rohan Teja, welcome, Rishikesh Kaushik, welcome, Harshit Royal, welcome, Raju, welcome, Ranjit, good evening Ranjit, good evening Sir Chandrakiran, good evening, welcome to Unacademy, welcome to Network Analysis and Transmission Lines course. Please do share it with your friends and ask everyone to join the session immediately, so that you'll learn many things. So what were we doing for this given question? We have taken T0 minus and T0 plus. We have observed that a T0 minus switch is open and a T0 plus switch is on, and inductor does not allow sudden change of current. So what happened was you get I of 0 minus and I of 0 plus as 0 amperes. Then we have considered the differential equation corresponding to the given RL series circuit. Then for that you got it as d, d di of 0 plus by dt value, it is 100 ampere per second. Then by using this same differential equation, we have differentiated this once again. Then we have got d square I of 0 plus by dt square. Now let's try to see one more problem. Let's try to see one more problem. So let's take one more question and let us try to solve that question by using the initial conditions method that we have learned just now. So you must have been aware of that. Now let us consider the question. Find I of 0 minus comma I of 0 plus comma di of 0 plus by dt comma d square I of 0 plus by dt square for the given question, for the given circuit. And the circuit given is something like this. There is a resistor and there is a capacitor, and you are given these values like this. The switch is closed. Let's say this is K, this is 10 ohms, and this is, let's say, 10 microfarad, and this is 100 volts. So now if you try to solve this, what do you get from this? First you need to write what is T0 minus and T0 plus. At a T0 minus, if you see, the switch is open, or you can also say it is off. And at a T0 plus, if you see, at a T0 plus, switch is closed or it is on. Switch is closed or it is on. Now let's try to take that, draw that diagram. So this is open or off. You have a resistor and a capacitor, and this is voltage 100 volts. This is off. Now whenever you have a off, current through this is equal to 0. Current through this circuit is equal to 0. And what is the voltage across this is equal to, voltage across this circuit is equal to, you do not have any voltage, so this is also 0. Now when you just switch it on, when you just switch it on, you have this as connected, and this is the capacitor that you have here C, and this is R, and this is on. So you have 100 volts. Now if you apply, because it is a closed circuit and the capacitor does not allow sudden change of voltage, but it will behave as a short circuit whenever there is a transient or whenever there is a switching operation. Now if you try to find I of 0 plus, what is I of 0 plus is equal to V by R. What is V? 100. By R value we have taken it as 10 ohms. So it is 10 ohms. So it is 10 amperes. But if you observe what is the voltage across capacitor, V0 plus is equal to, still it is 0 volts. So still it is 0 volts. Voltage across the capacitor does not change. Voltage across capacitor does not change, but there is a change in the current. Hope you are clear with this. Now let's say for t greater than 0. Let us say for t greater than 0, if you are writing the equation, just draw the circuit. Here switch is on and it has taken some time. Now let's draw that. This is switch is on. Here you have a resistor and a capacitor. So this is 100 volts, the resistance 10 ohms, and this is capacitor 10 microfarad, and there is a flow of current. Now can we write equation for this? Yes, we can write equation for this. So it is V is equal to R into I plus L. So this is a capacitor plus 1 by C integral I dt. 1 by C integral I dt. Now just try to simplify this. We'll try to simplify this. So V is 100 is equal to R is 10. R value of R is 10I plus 1 by C, 1 by 10 microfarad integral I dt. So this is an integral equation. Let's try to convert it into differential equation. So if you differentiate it, this is 0, this is 10 di by dt plus 1 by 10 into 10 power minus 6. Integral and differentiation will get cancelled. So we'll get 10 di by dt plus 10 power 5, we can write it as, into I is equal to 0. This is the differential equation. And what do we need? We need di by dt. Di of 0 plus by dt. So di by dt is equal to minus 10 power 5 by 10 into I. This is minus 10 power 4 I. Now what is the value of di of 0 plus by dt? It is minus 10 power 4 into I of 0 plus. What is I of 0 plus value? We already know I of 0 plus value, we have got it here. What is I of 0 plus value? 10 amperes. What is I of 0 plus value? It is 10 amperes. So just write it down. It is 10. So this is minus 10 power 5 ampere per second. What is that? Di of 0 plus by dt. What is the value of di of 0 plus by dt? It is 10 power minus 10 power 5 by minus 10 power 5 ampere per second. Now you are also asked to find d square. You are also asked to find d square I of 0 plus by dt square. So let's consider the same differential equation, this part. Consider this differential equation, or this differential equation, that is di by dt is equal to minus 10 power 4 I. Now differentiating with respect to t, you'll get it as d square I by dt square is equal to minus 10 power 4 di by dt. So if you want to write d square I of 0 plus by dt square, it is minus 10 power 4 di of 0 plus by dt, right? So if you just try to write this, what you'll get? So d square I of 0 plus by dt square is equal to minus 10 power 4 into, what is the value of di of 0 plus by dt? Di of 0 plus, if you can see, this is minus 10 power 5. So if you just multiply minus into minus plus, 10 power 9 ampere per second square. So this is di of d square I of, so d square I of 0 plus by dt square is equal to 10 power 9 ampere per second. So finally you can write it as, for the given question, just you just need to write everything. So we'll just write all the answers here. So what is the answer that we need to write? First, I of 0 minus is 0 amperes. Next, I of 0 plus 10 amperes. di of 0 plus by dt, it is minus 10 power 5 ampere per second. Next, what is the next part? D square I of 0 plus by dt square, it is 10 power 9 ampere per second square. So these are the answers required for the given question. These are the answers required for the given question, right? So this is the second problem. We have already solved one problem here. If you can just see, yeah, this is one problem that we have solved for the find I of 0 plus I of 0 minus di of 0 plus by dt, d square I of 0 plus by dt, and so on. Next, in the second problem, the same method, we have an RC circuit here. In the previous problem we had an RL circuit. So this is find I of 0 minus I of 0 plus di of 0 plus by dt d square I of 0 plus by dt square. So we have taken t I of 0 minus and I of 0 plus when the switch is open and when switch is closed. And for this we have just seen if it is off I of 0 minus is 0. If it is on I of 0 plus is capacitor will act as a short circuit. So you'll get 10 amperes. So after that we have applied KVL equation and tried to find di of 0 plus by dt and d square I of 0 plus by dt square. Now let's try to solve one more question. Let's try to solve one more question. The question given is, for an initially relaxed circuit, determine voltages and current at t is equal to 0 plus if switch is closed at t is equal to 0. This is the question. For an initially initially relaxed circuit, for an initially relaxed circuit, determine the voltages and currents, determine the voltages and currents at a t is equal to 0 plus if switch is closed at t is equal to 0. If switch is closed at t is equal to 0. And given question I have to draw the circuit. Yeah, let's take the circuit like this. This is 30 volts. There is a switch and a resistor and capacitor is given. You have an inductor here. Because to make it easy, I've just taken one simple examples in the previous, and now this is one problem that will be given in your exams like this. This is a switch. This voltage is something 30 volts. Resistor 10 ohms. This is 100 microfarad, and this is given as 10 Henry, and the resistance value is 5 ohms. Now first let us write at T0 minus separately. What is T0 minus? See, if you look at the operation of this switch, it is from off to on. So at T0 minus just before switching, T0 plus just after switching. So at T0 minus just before switching, switch is off or open. Now let's try to draw that. When switch is open, this is the resistor, capacitor, inductor, resistor is connected to the source, plus minus. What are the values? 30 volts, this is off, resistor 10 ohms, 100 microfarad, 10 Henry, 5 ohms. Now when you do this, what is the voltage? Sorry, current. I of 0 minus, because this is open, 0 amperes. Voltage across capacitor, 0 volts. So everything is 0. Now let's try to consider the second case. Now when at t is equal to just 0 minus I of 0 minus is 0 amperes. Now at t is equal to 0 plus. Let us consider at t is equal to 0 plus. At t is equal to 0 plus, if you consider switch is on. Switch is on. Switch is on or closed. Now let's try to draw the diagram for that. Let's try to draw the diagram. So you have a source, it is switch is closed, a resistor, capacitor, and an inductor and a resistor. Now in this case switch is closed. Now the switch is closed. Let's write these values also. So this is 30 volts plus and minus, 10 ohms, 100 microfarad, 5 ohms resistor, and this is 10 Henry. So when it is on, inductor does not allow sudden change of current. So this will be an open circuit. Capacitor does not allow sudden change of voltages. So this will be a short circuit. Now, with this, just try to write the equations. Now, what is I of 0 plus? I of 0 plus will be V by R total. What is V? 30 by what is R total? 10 plus 5. If you, when this is short circuit, we'll also draw its equivalent. Let's see the equivalent. You have a voltage source, a resistor and a resistor. That's it. This is open and this is short. So you'll get 10 ohms and 5 ohms. And this value is 30 volts. So 30 by you'll get 15 is 2 amperes. So what is I of 0 plus? I of 0 plus is equal to 2 amperes. I of 0 plus is equal to 2 amperes. Now voltage across 10 ohms. Let's try to find voltage across 10 ohm resistor at T0 plus. What is the voltage across 10 ohm resistor at T0 plus? It is voltage across 10 ohm resistor at 0 plus is equal to I of 0 plus into resistance. What is I of 0 plus? 2 into resistance 10. It is 20 volts. Similarly, voltage across 5 ohm resistor at T0 plus. Voltage across 5 ohm resistor at T is equal to 0 plus. What is that? Let's take it as V5 at 0 plus is equal to I of 0 plus into resistance. What is I of 0 plus? 2 into resistance 5. So this is 10 volts. So this is how you will determine voltage and currents. This is for an initial relaxation. Determine the voltage and current at T is equal to 0 plus. That is what the question that was asked. So that is at T is equal to 0 plus we are asked to determine the current and voltages. So just we have considered when switch is open and when switch is closed, and just try to operate and see. This is short circuit, this is open circuit. You get an equivalent circuit and find I of 0 plus. Once you have got I of 0 plus, it is very easy to find voltage across resistors. So this is one more problem. So this is very easy. We just try to understand about initial conditions. Now let's also look at one more question. Let's try to solve more number of questions. So the question is now for the circuit shown, determine the voltage and currents at T is equal to 0 plus when the switch changes its position from 1 to 2 at T is equal to 0. Now let us see that. The question given is for the circuit shown, determine all voltages and currents at T is equal to 0 plus when switch changes its position from 1 to 2. When the switch changes its position from 1 to 2 at T is equal to 0. At T is equal to 0. So let's take that question. So it is given there is a voltage source with some capacitor, and it is connected to a switch. Here there is a switch and you have another voltage source here. These two are connected together, and this is connected to a resistor with some capacitance Cy and an inductor. So this is the given question. So here you have these values as 20 volts, and this is given as Cx. Let us take this as 2. I have taken this question from one of the textbooks, Ravi Shar Singh, I guess. So this is Vx voltage, and here you have Cy, and it is given 10 volts, and here you have a current of 0.5 amperes. Now what is that it is given is, it's very important to understand this. The question given here in this case has two capacitors and one inductor. It has two capacitors and one inductor. Now also given Cy is initially charged when it is moved before it is moved to 2. Now if you observe, let's try to write this, first try to draw this T0 minus T0 plus, then you will be able to understand that very clearly. Now let's try to take this, and switch is moved from 1 to 2, that is what is given. So at a T0 minus, what is the position of the switch? Now at a T0 minus, switch is at 1. Now at a T0 minus, when switch is at 1, try to draw the circuit diagram. So that circuit will be, so you need not draw this, right? So this is a voltage source which has a capacitance Cx, which need not actually be mentioned because this is connected to 1. This is the 1 point. So you have a voltage source Vx, and there is a resistor here, and the resistor value is taken as 5 ohms. This is 5 ohms. So this is 5 ohms resistor, and there is a capacitor, and there is an inductor. Now when you try to take this at T0 minus, this is 5 ohms, and this capacitor, it is connected to this point 1 for a very long time. So when this is connected for a very long time, it starts behaving as a, behaving as a voltage source, and this will start behaving as a current source. This will start behaving as a current source of 0.5 amperes, and this will start behaving as a voltage source of value 10 volts because it is charged. Now let us draw at a T0 plus. Now when you take T0 plus, it is moved from 1 to 2. Now when it is moved from 1 to 2, you have 20 volt source that is connected to that with a capacitor, and it is connected to resistor along with this other capacitor and an inductor. Now even if when it is at T0 plus, the same thing happens, that the capacitor will act as a voltage source and inductor will act as a current source. This is 0.5 amperes and this is 10 volts, and this would be 5 ohms. This capacitance is Cx, and this switch is at 2 position. Now in this, to this you just need to apply KVL, apply Kirchhoff laws. If you apply Kirchhoff laws, what will happen? It is, let's say some current I1 is flowing through this. So you can write 20 is equal to pi I1 plus 10. Because this capacitor, when it is switched, it does not allow sudden change of voltage. It will become a short circuit. So you'll get I1 is equal to 20 minus 10 by 5 is 2 amperes. 2 amperes. Now when you get this as 2 amperes, see whenever this is 2 amperes, can we not write what is this? This is already 0.5. So what is the current? What is this current? This is I of 0 plus, if you try to write, what is the value of I of 0 plus is equal to 2 amperes, because I1 is 2 amperes. Therefore, I5 0 plus is equal to 2 amperes. And we have seen that the current entering must be equal to the current leaving. If you just look at this point, there is a current that is entering this point, that is 2 amperes. There is a current that is leaving. Let us try to consider this current as Ix. So what can I write? Ix is equal to, both are leaving current, so Ix plus zero point 0.5 is equal to entering 2. So Ix is equal to 2 minus zero point 0.5. So Ix is equal to 1.5 amperes. What is the value of Ix? 1.5 amperes. So voltage across the inductor, sorry, oh, this current here is zero point 0.5. So here you got the total values like this. Just look at this, everything. What have I done? So we are given a question. For the circuit shown, determine all the voltages and currents at t is equal to 0 plus when switch changes its position from 1 to 2 at t is equal to 0. Now when you are at t0 minus, when the switch is for a long time at this point, when it is at a very long time at this point 1, so the capacitor is already charged to 10 volts, and there is inductor is acting like a current source. Inductor will act like a current source and capacitor will act like a voltage source. So these two will act like voltage and current sources. And if you, this need not be connected because this is second position, and now the circuit is connected to the first position. This is the first position. Now when you take t is equal to 0 plus, uh, this switch will move from here to here, and it will be get connected to this 2. When it is connected to 2 capacitor, because it is suddenly connected to some source, it will not act like, it will not operate, and it will act like a short circuit. And even at t0 minus or t0 plus, the behavior of inductor and capacitor does not change, so it will act like a voltage source and this will act like a current source. So when you apply just KVL, you will get I of 0 plus as 2 amperes. It is current in 5 ohms is 2 amperes. And if you take Ix, if you take the currents, this is already 2 amperes, this is zero point 0.5 amperes that is flowing, and this current that would obviously flow into this voltage is 1.5 amperes. So this is how we will determine the the initial conditions of any given system. So this is how we will determine the initial conditions of a given system. Let's look back what we have solved. We have done what is transient state analysis and what is steady state analysis. The network that has storage elements like inductor and capacitor, if switched from, or there is a disturbance of state, it changes its state from one state to the other state. The state that a system undergoes before it reaches steady state is called as the transient state, and I've just represented this transient and steady state. So whenever it is operated, this point is called as 0 minus, this is called as 0 plus. 0 minus is just before switching, and 0 plus is just after switching. Just before switching and just after switching. Then I told you about the better quality. You need to click this and click on quality and click on this 480 also. Then the response of a system before it reaches its steady state is called as the transient state, and the response of the system after transients die out is called as the steady state. Now, I have also told you about these inductor and capacitor initial conditions of draw. So the total response can be written as the transient response plus the steady state response, and C of t is C of t and CSS of t. And I told you about switch operation, and initial condition is the state of the element or the system just before it changes its state. And I have told you about the inductor, capacitor and other things. and when it is switching, it will act as a open circuit and it will act as a short circuit, right? Then we have taken up some problems. Then I told you about the switch operation like this. How will a switch be? It is open or off, and when it is closed and on, uh, and the direction of the switch, you have to take care of that. Then we have taken some problem to find I of 0 plus I of 0 minus d of 0 minus a of 0, d square of I of 0 plus by dt square, and di of 0 plus by dt. In this, if you see t is equal to 0 minus t is equal to 0 plus, we have taken two conditions and we try to draw the diagrams for the both and get the equation, get values of I of 0 minus and I of 0 plus also. Then by applying KVL we got some equations, and to that if you apply the initial condition again, you got di of 0 plus by dt. If you take the same equation and differentiate it, you will get d square I of 0 plus by dt. Next to the other question, the same second question, there is also another question which is an RC series circuit. We are asked to find I of 0 minus I of 0 plus di of 0 plus by dt, d square I of 0 plus by dt square. Then we have taken this 0 minus and 0 plus and switch as open and close. Then switch as open and close. Then we try to draw the diagrams. This is one diagram, this is one diagram, and this is the other diagram for t0 minus and t0 plus. Then we try to take values of I and V at t0 minus and t0 plus. Then we try to do take the equation, right, apply KVL equation. Then we got what is dA of 0 plus by dt. The other value we also got d square I of 0 plus by dt, where we'll substitute the dA of 0 plus by dt value. Here also we'll substitute I of 0 plus value. So this is how you will determine that value. Then we have taken one good problem, sorry, wherein we have a 30-volt source which is connected to 10 ohms and also 100 microfarad and 10 Henry and 5 ohms. And we are asked, it was told it is initially relaxed, and then if the switch is closed at t is equal to 0, we try to do this values at t0 plus, and I of 0 plus is found, and we also found voltage across the resistor and voltage across 5 ohm resistor and voltage across 10 ohm resistors also. Then we took one more problem wherein it is already charged, the capacitor and the inductor are already charged. So because they are charged, we took voltage source in place of a capacitor and current source in place of an inductor. Voltage source in place of a capacitor and current source in place of an inductor, and then we have tried to find the values. We have applied KVL first. Then we have found what is the value of I of 0 plus 2 amperes, and then I of that means that the current through 5 ohm resistor is 2 amperes. Then we try to apply KCL at this node, so that we got Ix is 1.5 amperes. So let's try to write these at t0 minus and at t0 plus, the different values once again, and see some. Now for t0 minus, so for t0 minus, the capacitor is initially uncharged, initially uncharged capacitor. If you are taking, that means this capacitor is initially uncharged. Plus minus. So that means what is charge? Q of 0 minus is 0. That means QC of t will be C of Vc of t, that is Q of 0 minus is equal to C into Vc of 0 minus. Therefore you'll get Q of 0 minus is C, Vc of 0 minus. Therefore Vc of 0 minus will also be equal to 0 volts. Now at t is equal to 0 plus, at t is equal to 0 plus, capacitor follows the law of conservation of charges. Capacitor follow law of conservation of charges. Capacitor follows law of conservation of charges. So QC at 0 plus is equal to QC at 0 minus. So VC at 0 plus will be equal to VC at 0 minus. So that is voltage across capacitor. Voltage across capacitor cannot, cap cannot change instantaneously, right? So at t0, that means voltage at C of VC of 0 minus and VC of 0 plus is equal to 0 volts. That means it will behave as a short circuit at t0 plus. Now if you consider at t is equal to infinity, t is equal to infinity. So when it is t is equal to infinity, if you are looking at that at t is equal to infinity, you can take it as, now let us look at t0 minus, it is initially uncharged, so you get Vc is equal to Vc of 0 minus is equal to 0 volts. Now if you take t0 plus, it is Vc of 0 plus and Vc of 0 minus both are same. Vc of 0 minus is 0, so Vc of 0 plus is also 0, so it is acting like a, it is acting like a short circuit. Now at t is equal to infinity, if you consider, let's say capacitor is fully charged. If the capacitor is fully charged, Vc of infinity is equal to, it is a constant value. So Ic of t is equal to C dVc by dt of t. It will be a, this will be the value. So if you take Ic of infinity is equal to C dVc of infinity by dt, then Ic of infinity is equal to 0 because this differentiation of constant is 0. So this is how we can write the value of capacitor at t is equal to 0 minus 0 plus and t is equal to infinity. So this being an open circuit, this being a capacitor is current through this capacitor as 0, it will be an open circuit at t is equal to infinity. At t is equal to infinity. Now let us consider the inductor. The same, in the same way, let's also consider the inductor. Let us consider inductor. Inductor at t is equal to, at t is equal to 0 minus, at t is equal to 0 plus, and at t is equal to infinity. If you just consider this, now if you have an inductor which is initially uncharged, if I say, if this is uncharged, you can write, and let's consider the voltage as VL of 0 minus. So flux is 0 minus is equal to 0. So phi of t is equal to L into I of t, that is at t is equal to 0 minus. So phi of t is 0, that is because this is given already. Therefore I of 0 minus, current through an inductor is 0. Similarly, if you take inductor also follows law of conservation of flux. I'm sorry. So phi of 0 minus is equal to phi of 0 plus. Phi of 0 minus is already 0, so phi of 0 plus will also be 0, and therefore IL of 0 plus is equal to IL of 0 minus, which is already 0 amperes. So this will give you, it will behave as a open circuit. It will behave as a open circuit. Now if you just take the same at t is equal to infinity, if it is IL of infinity is equal to a constant value, and what is VC VL of t is equal to, it is L DIL of dt by dt. This being a constant, voltage across inductor is 0, so it will act like a short circuit. It will act like a short circuit. So this is the basic idea of how we find the value of inductor and capacitor, how they are short circuit and open circuit at t0 plus and t is equal to infinity. So this is all about the initial conditions. So we have India's number one study channels: Creatrix GATE, Unacademy GATE MEPI, Unacademy GATE. We also have Unacademy GATE Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy GATE Questions, Unacademy Electrical Junction, Unacademy Engineering Foundation, Unacademy Pathshala. So please do like this video, share this video, use my referral code YSK10, and subscribe to our channel Unacademy Semester Exams, and click on this bell icon to get notification of my classes and get a maximum discount of 10% on your next Unacademy subscription. And today we have learned initial conditions. We have learned what are initial conditions. Stay tuned with me. You'll also learn many more things about these transient and steady state analysis very soon in the upcoming classes. And in this video we have solved what are the values of I of 0 plus, I of 0 minus, di of 0 plus by dt, and d square I of 0 plus by dt. And I also told you about what is transient state and what is steady state, right? And we have solved some problems on these concepts. So thank you all once again for joining me on this session on network analysis and transmission lines. We are dealing with transient and steady state analysis. Thank you.